which delivers more heat at the equator than at the poles. So hot air rises at the equator and flows poleward over our heads. Then cooler air moves in across the surface toward the equator. This circulation is called a Hadley cell. For various complicated reasons, Earth doesn't have just a single atmospheric cell in each hemisphere. We actually have three: Hadley cells, Ferrel cells, and polar cells. Let's assume our rotated world has the same situation going on. This means it would have temperature extremes which are similar to ours. Here's what a map of our rotated Earth looks like. We'll add some ice and permafrost near the poles and in mountainous areas. Next, we should fill in some green areas and deserts. The locations of these depend heavily on rainfall, so we'll need to sketch out some winds. Because of the Coriolis effect, the surface winds in a Hadley cell flow not just toward the equator, but from east to west. In the temperate zones, the prevailing surface winds are west to east, and at times there are also east to west winds circulating around the poles. So let's fill in some wind patterns, keeping in mind that in reality things would be further complicated by land interactions and the locations of persistent high and low pressure systems. The rising air at the equator carries moisture from the ocean, which then condenses into